Hallo, schönen guten Tag, liebe Festivalgäste zum zweiten Festivaltag.
Hello and welcome to the second day of our festival. Welcome to our panel discussion program in the large hall. First, the keynote held by Professor André, and then the panel discussions. Toby Walsh, in his keynote speech, took us along on a journey into the year 2026, 2062 rather, and now he also said that by that time computer intelligence will be as intelligent as we are. Professor André will talk about what artificial intelligence can already do today. Where do we encounter it in day-to-day lives? 3:30 and 5 p.m., the influence of artificial intelligence and its impact and problems in politics and in the economy, platform capitalism namely, 3:30 and 5 p.m. There have been a few cancellations due to illness. Sabine Müller-Mall is ill and cannot take part in the panel discussion on politics and AI. Professor Jeanette Hoffmann will stand in. She is a professor of internet policies at the Free University of Berlin and also a specialist in this field. Thank you very much. For the panel discussion on platform capitalism, Svea Windwehr had to cancel, a senior analyst at Google. Unfortunately, it has been at such short notice that we couldn't find a stand-in, but it's still a top-notch panel. The DJ in the entrance hall will also change. DJ Lux will be replaced by DJ Empfa from Leipzig, and he will present something that is in line with the title of the festival. And his label is called Joy or Luck. That program, that artistic program, will start at 6:30. First, Schaufler Lab with a program on AI and an artistic view on AI, so how Schaufler Lab exhibits in a Turner Gallery and what they do at Katana Gallery. And for our literature night at 8 o'clock, Emma Paslavsky and Dietmar Dart, they are still our presenters. Some housekeeping issues, a few words about Professor Elisabeth André. Afterwards, you can ask questions live from the audience, but don't be surprised. Vincent is sitting over there, and the keynote speech will be streamed live on the internet, so he's waving. If you want to ask questions using the chat function, you can ask questions online. So whenever that lamp is on, there is a question from the chat, and we will pass it on to Professor André. Artificial intelligence, where can it help us and what should we know in order to use it in a reasonable way? Elisabeth André is an IT professional. She has the chair of human-centered intelligence at the University of Augsburg. She concentrates on new technical methods, looking into the human-computer interactions. This year, she was awarded the Leibniz Prize for her work. It's the most prestigious prize awarded by the German Research Association. And in 2015, she was named as one of the 10 most important people in the German history of AI. Thank you for being with us and for giving us an overview of AI. Thank you very much for that introduction and the invitation. I'm particularly happy to be able to present in front of real people. For the last 2 years, that has been a rare event. Techniques of AI and AI technology over the last couple of years have created quite a stir. over the last couple of years by mimicking intelligent skills like the recognition of traffic signs, the writing of articles, or the composing of music. All that has led to high expectations. But what can artificial intelligence really do? And which skills do we need in order to put it to reasonable uses? And I would like to give you an overview of that in my presentation. Artificial intelligence is not an invention of the Silicon Valley. Sometimes you may get that impression when you read articles about AI. AI has been around for a long time, has been an active field of computing, and the founding event was the famous Dartmouth Conference back in 1956. In this slide, you see some milestones in the development of AI, like the invention of the backpropagation algorithm by Rumelhart and his colleagues. With this algorithm, it became possible the way to adapt the weighting of neural networks through backpropagation of fields in such a way that you could reach a desired behavior. As we couldn't always come up to the high expectations of AI, since 1956, there have been 2 AI winters where the interest in AI dropped in a major way, dropped a lot. You see this blue curve, it doesn't always skyrocket or go steeply up. Progress in terms of hardware since 2010 have fostered the development of deep neural networks, which have led to this present hype in terms of AI. In our professional and day-to-day lives, we continually encounter techniques of AI without being aware of it all the time. Good examples are speech assistants like Alexa and Siri, which give you a weather forecast, remind you of important appointments, or with voice commands regulate heating or light. In industrial manufacturing, robots help people by doing assembly work. In diagnostics and medicine, AI techniques support doctors in crucial decisions. In Augsburg, we recently founded a department of medicine and AI, and their interest in our technologies are big. We look for information in the internet, web shops generate recommendations, and progress in image processing has led to progress in autonomous driving. So just a few examples. The feature of the AI applications I've mentioned means that in predetermined fields, AI does complex tasks which don't have to be specified by human beings in great details. In the old days, we had rule-based systems where a human being had to do a lot of coding by hand, and nowadays systems learn new things under their own steam. In some fields, machines are even better, have become better than us. For instance, classic example, playing chess. But this is already true for image processing, for medical purposes, for instance. With the so-called Turing test, Alan Turing, back in 1950, developed a process in order to see whether a machine can think in a similar way as human beings. And this Turing test works as follows. During this test, a human being uses a keypad and a screen without seeing or hearing the machine, and that human being is not told whether he or she is communicating with a human being or a machine. And If he or she cannot make up their mind whether the image or the output in this screen was made by a machine or a human being, the machine will have passed the Turing test. 2016, an editor, Retro Schneider, you can still read that article, retrieve it from the internet, and he won an award for that, and justifiably so. Great article. Mr. Schneider came up with several tasks where he engaged in a duel with the machine. After 6 duels, there was a draw. It was about chess, and where he lost, recognizing the age of people on the basis of photos. Here, surprisingly enough, he also lost, and he was surprised about what the machine had done and how it had done it. And it was about understanding speech, where he won. So 6 duels, and with a draw as a result. So there was a tie, and that was some time ago. Modern processes of machine learning are inspired by how interconnected biological nerve cells work. The human brain, however, is very complex, and we don't yet know sufficiently enough about it in order to have a computer mimic a human brain. However, with deep neural networks, we have had surprising successes. So just a few examples, namely voice processing. GPT-3 is an example, the most complex speech model of our times, which has been trained with all available information from the internet. You can imagine everything there is, Wikipedia, and you can imagine that such a speech model must have accumulated a lot of knowledge, and the capacity of this speech model can hardly be distinguished from human beings in some fields. For instance, when translating texts, when answering questions, or the generation and the writing of newspaper articles. Sometimes I use machine translation as well, and sometimes the machine translation systems have better suggestions than I myself. Not always, but very often, and that is a bit frustrating. GPT-3 doesn't have as yet as many parameters as the human brain, but GPT-4 is already in the pipeline, GPT rather, and has even more parameters than the human brain. A few more words about speech processing, but because this is a classic example for the use of neural network, and a lot of you will have used speech assistants or have worked and interacted with those regularly. You have the impression, at least from time to time, that you are facing a human being, a human counterparty. On the other hand, there must have been situations where you realized that the speech assistants don't even understand what it is all about. Just say something. I would like to say a few words about the technologies where this is based on. I will focus on neural processes, which are based on word representations, which reflect and mirror the meaning of words. So just briefly, what is the meaning of a word, and why will I explain something about the technology? If you have a rough idea how the systems work, that will help you using them in a reasonable way. Surprisingly enough, the meaning of a word works as follows. This is not a quotation from IT, but a quotation from a philosopher, by a philosopher, namely the philosopher Wittgenstein, who very early on, or who I read very early on when I worked on my PhD. thesis. It was about the automatic generation of multimodal representations. So Wittgenstein says the meaning of a word is the result of its use. Here you see a text with the word dibbelabbes. So it's a dialect word from the Saarland region. I don't have to explain it, so let's read the text. Dibbelabbes with applesauce. Every child knows in the Saarland region. Hans explains how to distinguish dibbelabbes and Schales. The recipes are simple and good. The products are regional. The participants can look forward to dibbelabbes with applesauce and a wonderful place to shoot a film in the Saarland region. So there is no definition of dibbelabbes and Schales, but everybody reading this text can tell dibbelabbes must be a local dish from the Saarland region, even though the word is not even explained. So this is the basic idea. By using words in a context, by seeing words in a context, can I tell what those words mean? And now the question, how can an algorithm work? What can it look like? And can it understand the meaning of a word based on the use of the word? And how can you represent the meaning of a word? The basic tenet is, the assumption is, that words which occur in a similar context have a similar meaning. So dibbelabbes and Schales, German dialect words, occur in similar contexts, so they must mean something similar. So it must be to do with eating, with a dish. Based on this assumption, we can represent a word as a point in a multidimensional semantic space and can name vectors and can have vectors representing the words, and they are called embeddings. So a mix of linguistics and philosophy in order to automatically understand the meaning of a word. So for practical purposes, what is the advantage of such vectors and of using such vectors in analyzing speech? In earlier approaches, when analyzing speech, the use of a word was used as features, and you had to find out those features manually. Here, for instance, from the occurrence of a word, so of positive words like wonderful, you will see that it must be a positive text. When you have such a test data set where the word jolly good is used, with earlier approaches we would understand that only when exactly the same word occurred in the glossary, in the lexicon. However, when we use it as a feature, we can generalize it. When in a test data set we encounter a similar vector, even though this vector was not part of the training set. It may sound complicated, but I will now use an example to explain what I'm getting at and what you can do with that. Here you see distances in an n-dimensional space representing similarities of words. You see, for instance, cat, fox, bird, and dog are close by, and they are further away from juice, water, milk, and tea. And you get these clusters by applying the algorithms. What is interesting is the following. You can do analog drawing of conclusions. For instance, bread relates to a baker, like meat to, well, what? And when you base it on these similarities, a system will hit upon the idea as meat to butcher. Those word embeddings can be used in order to derive similarities and relationships between words. There are many ways of comparing words. Big is similar to bigger in the same way as small and smaller. Good and better are similar as well, but this is a different similarity compared to a similar context. For instance, good and bad will occur in similar contexts, hence the word representations are similar, and this can be a problem when we want to determine what the mood of a text is and when we want to do that and bring that across automatically. A few more examples about calculations. Oh, let's have a look at the first one. King minus man plus woman is queen. France without Paris plus Berlin is Germany. So France relates to Berlin, or France relates to Paris rather, as Germany to Berlin. Father relates to man as mother to woman, and such relationships can then be derived. However, this only works when you try it out for words which are frequent, for little distances, and relationships like between countries and their capitals. Well, what else can you do with that? Word embeddings can mirror, can reflect some kind of change of meaning. If you train word embeddings with historical texts, this makes it possible for us to look into changes of meaning across the centuries. Stanford University did that. Researchers at Stanford University did it with historical texts. One example, the one in the middle, when we have a look at the English word broadcast in the mid-19th century, this had the meaning of sowing seeds. So it was from agriculture. And with television and radio, the meaning changed towards transmitting signals. And this is a good thing you can do. I have already mentioned this. I've given you examples, like, for instance, man relates to father, like woman to mother. And when you have similar tasks with historical texts, you will realize man relates to rich as woman relates to pretty, and similar things which make you think. So word embeddings can also mirror and reflect cliches, and in this slide you see some examples which I generated quite recently. Superman relates to man as woman to superwoman. Well, no two ways about it. That makes sense. You cannot really criticize it. But also extraordinary professor, untenured professor, relates to assistant professor as man to woman, or even worse. Extraordinary professor relates to assistant professor, like American to African. So I found that out recently by trying out the system in order to demonstrate it to my students. And you can easily imagine when you use these processes in systems which are crucial and decision-making. For instance, when appointing somebody for job interviews, you may not come to a good decision because, like us, those systems are subject to cognitive distortions and bias. And this is not introduced by AI. This is a mirror of our society. Very often, people will say, this is bad, that this is what the system comes up with. Well, it's bad if you use those systems or base your decisions on it, but to say it must not happen, even though it occurs in society, well, this would be concealing facts which do exist. with such word and sentence embeddings. We had big success with dialogue systems. The big advantage is that such representations can be built automatically with huge amounts of speech data. You don't have to do it manually. You feed a machine with lots and lots of speech data. That's your input, and then the machine will start off. You can see from these examples in this slide that the systems usually simulate dialogues without understanding them. This is an example of 2015 when you ask a machine, so this is a special machine, when you ask a machine, what is your job? And the machine answered, I'm a lawyer. If you put the question a bit differently, what do you do? Then the machine will say, I'm a doctor, which is a bit of a contradiction, so not so great. This is to do with the fact that the meaning of words is represented with contexts or using context. The systems hallucinate as well. This was what a colleague of mine did. He asked a question about a renowned scientist, admittedly, so some things are true. What the system knows about this scientist, but some things are not true. In this case, the system has hallucinated, has had hallucinations. For instance, the system says, he is the most intelligent person on earth, at least in my humble opinion. So it's funny. I tried it myself and I couldn't get the same result. That's why I gave you my colleague's example. But what I did is I conducted a talk with Plenterbot by Facebook. And the aim was to design an empathetic bot. So I told the bot, I'm having a food allergy, and the bot said, I'm sorry. You can wonder whether the bot was indeed sorry, but that's okay. That's what you would expect. Later, I'm told that the bot also suffers from a peanut allergy. You may wonder, well, what kind of bot is that, having a peanut allergy? And later the bot tells me, well, I don't have a peanut allergy after all, I just don't like peanuts. So it's quite entertaining to talk to such a bot. And you've got the feeling that the bot has feelings, but the illusion is dispersed because a deeper understanding is missing. On to the next related topic, which I would like to highlight. Can machines have emotions and understand emotions? And I would say straight away that it doesn't always make sense to provide a machine with emotional behavior. More and more everyday users encounter smart machines, for instance, personal assistants, and here it can be an advantage to simulate emotional behavior. So there are applications where it do make sense. Since the 90s, I've looked into virtual characters, and we have tried to find out what do they need, how do I have to design them. And I was thinking about it, should they have emotions, should they be equipped with emotions? We got our motivation from Disney characters. Disney characters wouldn't be so touching, wouldn't touch us, wouldn't move us if they couldn't bring across emotions. And Joe Bates already said that back in 1994 of Carnegie Mellon University, Joe Bates. In a BMBF project, we looked into the development of robots, social resonance, made by naval robotics. The robots were made by naval robotics, and our task was the detection, the recognition of emotions. I will play a video. I think the robot is quite cute, not quite finished. Hi, Claude. Everything okay? Yes. And you? Thank you. Everything is well. Do you want to play with me? No, thanks. I have to work. Oh, poor you. Good luck. Ciao. Goodbye. So we made a point of keeping it simple, keeping it straightforward, and it's still a lot of work. So the robot looks friendly and natural, so it involved a lot of work. For instance, the movement of the eyes was quite difficult. What do you need for that? What do you need to build empathetic machines? You need robust processes in order to detect emotions. Here, for instance, methods of machine learning, but you need more. If you want to put yourselves in the shoes of the user, a machine has to be able to have a look at the situation from their point of view. It's not sufficient to interpret somebody's facial features. And but if you don't understand why a person is feeling bad, that would be it. And if you simulate it, you have to be able to react to the emotions of users. Here you see a robot having synthetic skin and hence can express emotions in their faces. In dialogue systems, well, you can resort to a language channel to analyze emotions. Emotions, by and large, can be derived from the semantic meaning of utterances. For instance, when you say, I don't feel well, but also from acoustic features. For instance, energy, spectrum, or pitch. And here you can see the same sentence, once joyful, twice sad, with different speeds, uttered with different speeds, and the utterances are different by the contour of the pitch, seen in black here. In the case of sadness, the voice is more monotonous, doesn't vary as much, and you can see it very well from these curves. Of course, it's not all that simple, but it gives you an idea. And another channel, which is very expressive, is the face. And here, very often we use the facial action coding system. It was not developed by computer scientists, but Paul Ekman, a psychologist. And the basic idea is to bundle the muscle movements in groups that make sense, the muscle movements of an emotional facial expression, to provide names as a reference, and thus you get a coding to have a notation of facial expressions. The coding system knows 40 different elementary movements, and you can assemble complex mimic or facial expression from that. If somebody is surprised, they will open their eyes wide, their mouth will be round and open, and they will raise their eyebrows. When you have a look at photos of people, and then you get the task, which action units are involved, and then you have to do the coding, action unit 6, 12, and 25, and then you will get the idea that the person is joyful, is full of joy. So you need a lot of time for that, but in the meantime, there are processes which can do that very well. So every one of those two corresponds with unit, and here a machine can do it in real time. A psychologist told me that the processes are not 100% correct, but the alternative would be that somebody would have to do it manually. For instance, in order to do research or to find out whether reacts in a normal and natural way. When you have a look, you could have the idea machines are perfect, can detect emotions perfectly, and a lot of people are afraid, well, this is terrible, machines can read thoughts, they know about my emotions, but it's not sufficient to analyze muscle movements in the face in order to find out what a human being feels. And for that, we will have a look at an example. This is an interview. Two ladies are involved. On the left, the lady is criticizing the outfit of the interviewee. Where do you have this outfit from? It doesn't suit you very well. And what does the interviewee do on the right? She is smiling. And systems today would say, well, the lady on the right is happy, but it's clear if you are confronted with such a statement, you are not happy. So I will show you what systems would derive or what a system would do. So this is nothing special about the system that it cannot detect this, but all systems would detect that the lady was happy.
Und herauszufinden, wie man das jetzt verbessern könnte, bietet es sich an, dass man jetzt mal menschliche.
And now we wanted to compare attention of human beings and of artificial intelligence. In order to do that, we will have a look at a woman on the left-hand side, apparently tears in her eyes, and with AI-based processes, we know which regions of the image the AI uses in order to analyze the emotion displayed on the face. In comparison to that, we used eye-tracking mechanisms to find out what human beings would focus on. So we could find out which regions they focused on in comparison. And what we see is that the AI machine and human beings both focused on the eyes, which is logical, which only makes sense. But if we put this into a bigger context, then we realize that the analysis of the emotional state the woman is in changes, because the woman holds the Academy Award in her hand. So she apparently is moved to tears because she's so happy. And the machine will still entirely focus on her face, while a human being will look around to search for more context in order to understand why she is happy. Because she was the first Black female actress who won the Academy Award. Interestingly enough, when I show this example, then some people can even tell us that she is moved to tears because she's happy, because they know the actress and they know that she won the Academy Award. So a human being can use their knowledge when trying to understand emotions. How can we simulate that? One option is not only analyzing behavior, but also conducting a simulation that will show us how a healthy person would feel in different situations. So if we go back to our job interview, then we realize that something happened that was not very pleasant for the applicant. The emotion which you would normally feel would probably be shame. And shame usually results in blushing or the person hiding behind her hands. However, that's not what the applicant did in the picture we just saw. And that might be due to the fact that she tried to regulate her emotions. Again, it doesn't make sense to search for other approaches from other scientific disciplines. Donald Matterson, a psychologist, identified different strategies in order to regulate shame. One of them being trying to avoid the situation entirely by trying not to look at the interviewer's eyes. Another strategy is based on attacking the other person, for example, by asking her, why didn't you tell me that I had to choose another more appropriate outfit? Or they could even admit that it was their fault and say, I'm sorry that I wasn't prepared and put on a more formal dress. Based on data sets, we can then calculate different probabilities for these 4 strategies in order to regulate shame in different situations. And then we can try to compare them with the signals that we observe, which was smiling, trying to look away, and different body movements. This example is to show you that the way we interpret effective signals is a very complex matter, and that it is not sufficient to analyze behaviors alone. The last part of my presentation, I would like to answer the question of how we can use AI in future. I would like to present different applications where human beings are not being replaced, but where they are rather enabled to do things that they would not be able to do without the AI. Many different routines use machine learning in order to copy human intelligence. And the question is vital. Can computers be as creative as human beings? Humanoid robots, for example, as a news presenter, as a receptionist, as a music performer, and as a painter. Here, the robot is in direct competition with the human being. However, we should ask ourselves whether it does make sense to develop machines that are more intelligent than we are. I really like this slide. You see Kasparov, one of the greatest grandmasters of chess of all times, but still he lost when playing against an AI. When you look at the desperate way, at his desperate way of looking, then you have to ask yourself whether it really does make sense to develop a chess computer that is unbeatable. Maybe we should rather develop machines that inspire us and help us improve ourselves, further develop. And actually, it is a greater challenge to develop a computer that makes sure that we have the most fun possible instead of developing a computer that can beat us. If you look at this slide here, of course, an artificially intelligent machine will beat a human being. But this game was about making sure that this woman has fun playing that game and training her memory skills. I am always inspired by Douglas Engelbart, the inventor of the computer mouse, not because he invented that, but because in the 1960s, he realized that this was not about replacing human beings, but rather about augmenting human intellect. In fact, the question of how to shape cooperation between humans and machines is a critical question. The main idea of Douglas Engelbart originated in the 1960s, and he said augmenting human intellect should be the main issue, and that really inspired different research projects. I believe that we should use artificial intelligence in order to make progress as society. For example, in order to handle the increasing complexity of the environment that surrounds us, or to tackle different challenges that affect our societies. and that have been affecting societies for some time: health, climate change, demographic change, and finances. At our chair, we investigate whether we can use AI technologies to improve interpersonal relationships. This slide shows Jan Oliver Wölfing, one of my doctoral students. In the framework of his study, he deals with the development of an AI-based communication tool that is to support people who have a language disorder in order to communicate and articulate themselves in a natural way, and to also display their emotions in the form of speech. So that is to support people whose speech is impaired and they cannot express that something is urgent because the voice does not modulate and is always very at the same level. So he tries to help people who cannot communicate or not sufficiently enough in order to express their emotions. Jan dealt with increasing the possibilities of expressing emotions. We have other studies that focus on the exact opposite, which was to augment the sensory perception. The idea of a study from 2016 was to make it possible for blind and visually impaired people to scan their environment. If they look at an object, for example, a headline, then the user will be able to understand what he or she is seeing based on acoustic sound. And with the support of the Bavarian Federation for the Blind and Visually Impaired, we were able to test this program. It didn't work with everyone because the prerequisite was that these people had to be able to control the way they looked at things, their eyesight, and those who were able to understand more about the environment surrounding them. In the area of emotion recognition, we conducted different studies, and that is why we also dealt with the question of the sonification of our social environment. Imagine you're in a certain situation in which you cannot see sufficiently enough. You meet a group of people and you wonder whether these people are interested in talking with you or whether they're distracted. We tried to imitate facial expressions by using instruments, and I will show you a brief video so that you know what I'm talking about. The yellow dot is where the person looks at, and as you see the dot moving, you realize by means of the instruments that the face the person sees is a happy face. This is another project that we are conducting at the moment called Avazac. Here we develop a real-time control 3D sign language avatar for machine translation of German texts into sign language. With this project, we want to try out ML technologies with other methods that can imitate text in terms of, or translate texts in sign language. It is a very complex task that has not been solved entirely yet. I will show you 3 videos to show you what our general approach was. What we needed, or what the AI needs, is data and material in order to be trained and in order to learn. So we recorded German Sign Language as an input variable for the AI. Here you see a sign language. Hello, as a sign language avatar, I am going to tell you about your journey. I will tell you whether your train is on time or whether you need to go to a different platform. This is the information I will provide. The train to Hanover will leave from platform 8. So you record everything, and what happens next? Based on the recordings, the sign language I used is then fed into the system, and the goal is to train the avatar, the AI. For example, when it comes to the understanding the word train, that is why I'm making these recordings, in order to feed more input into the system. So as you can see, a lot of data is required in order to make the system work, and we're still trying to feed these data into the system. That is the major challenge we're facing at the moment. But that is not enough. The machine does not only require sign language input, but it needs to be told what these facial expressions and what the gestures mean. And that is a very complicated task. I was telling you about the facial coding system that helps us coding facial expressions, and here we need to code sign language. This is another video. The notation is this. The avatar does not know anything. It has to learn everything from scratch. So I write down everything that the avatar has to know about sign languages. I type in every term of the glossary, and I will also write down things about how the head moves, the cheeks, the eyebrows, the entire body. So that is the input I feed into the system. The avatar needs to understand this, just like a person would have to understand about this that learns sign language from scratch. And then I will choose whether the sign language the AI chose is correct. So all of this takes time because the computer needs to learn everything from scratch. This is the final result. This is another example that shows how we try to help people handle difficult situations, emotionally difficult situations. Hardest is a good example here, and PAT is the follow-up project. We use a virtual character that speaks with adolescents or adults, in this case adolescents, to train them for a job interview, because most people associate negative feelings with job interviews, for example, anxiety or nervousness. And by using role plays with a virtual character, these people can learn how to handle difficult situations, or to even try out different strategies that they would find hard to implement in real life. We tried this out at different schools, and we realized that the interaction with this game resulted in positive impact, as the students learned more than if they simply had read a book or a brochure about what to do in a job interview. Interestingly enough, as long as participants really participated, then the success was very high, and the character does not have to understand everything the user says in order for this project to be successful. Let me show you one example.
First, I would like to ask you, how are you? Are you excited? Hello, I'm Johnny. Thank you very much for inviting me for this interview. Well, I'm a bit excited. Have a look at the following cards. Could you please describe your strengths? My biggest strength is teamwork. Actually, I'm a very good team player. In this round, you were very convincing. And now my last example I would like to show you. This is the training of coordinated movements with a social partner. So lots of joint work, like the carrying of objects. Don't just need social actions like eye movements, but also coordination of movements with another person. For instance, if you imagine you have to carry something very heavy, for instance, a piano, and you need to carry it with somebody else, you need social coordination and coordination of your movements. With colleagues in France, we looked into it, whether we can build something which would facilitate such training. The idea was such a virtual figure being projected onto a screen, and then real objects, real items which are to be moved. I show you a short video so that you can imagine what is going on. The objects are fastened to the screen, to the wall, with magnets. What this is about is that you don't carry it yourself, but you wait what the partner is doing. We are testing this. We are testing whether you can train coordinated movement. My conclusions: natural behavior, or systems have natural behavior which give you the illusion of social skills like empathy, but only for brief interactions. True empathy needs a true understanding of contexts, of situational contexts. But even with limited understanding, there are coaching applications which make sense. The technologies can serve as a mood booster, and social robots are better than having no social contacts at all. Nothing can replace a human being. Also, a living pet is better than a robot. But if somebody doesn't have anybody, another human being, nor a pet, then a robot is better than having no contacts at all. The increasing complexity and missing skills of explanation of AI systems contribute to its mystification. As machines become better and better, they compete with human beings. So you have to think about it, how to improve and use the technology. What is important is for transparency, or you have to make sure that there is transparency so that the systems are used in a reasonable way. A doctor has to understand how a machine comes to a certain decision or diagnosis. Then it's important to tap the synergies between human and machine cognition rather than replacing people. So human beings and machines should improve as a team. You should optimize cooperation and not just optimize the AI systems. For that, we need a better understanding of the role distribution between human beings and machines. Thank you very much for your attention. That's all I had wanted to present. Thank you very much, Ms. André, for this exciting presentation and your overview and your insights into AI research. You have stated the aim that we want to create something that supports human beings, makes for a better life. and not, as we will discuss later on, where technology is used partially or in some cases to have surveillance of people or to manipulate people. So a very thrilling insight. So you talked for 1 hour. Now there is a round of questions and answers, not quite as many as we had in mind, as we want to continue on time at 3:30. Looking around, well, apparently there is one question. Just stand up and fire away. This question, unfortunately, is off mic. I will try and summarize it later on when the speaker is answering. The answer is similar techniques can be used, but this is multimodal, and hence the search space is even bigger for that. It is basically a translation task. Translation works very well with the speech models, works very well with the representations, but at the end of the day, this is the method of choice that you learn representations. We thought about it as this is a very complex problem, to do this as some kind of intermediate step, that we learn an intermediate language, a go-between language, which expresses the meaning, and then we translate that into the avatar's gestures. So we don't do it in a direct way. It's not a direct path. So 3 questions for my better understanding about your presentation, where the conclusions were a bit brief or a bit too quick. The first one was vector programming for speech recognition, where you mentioned discrimination. Did I get that correctly? The example was extraordinary professor relates to assistant professor, like man, and then apparently the computer added automatically women or American to African. So the logical system the computer had, extraordinary professor is higher, has a higher rank than an associate professor. And then the processing algorithm for the next notion was, well, when it was man, so I have to look for something that is lower than man, and this discriminatory algorithm of the computer can be seen by the automatic output woman. Answer: the computer doesn't attach any value to that. The computer just has a look which words are used in which contexts, and then relationships like that can be calculated. With similarities, well, that brings you to this conclusion, like in this example, assistant professor relates to extraordinary professor, like woman to man, by basically calculating those angles. And whatever adding that, is that what the computer does, complementing that? Answer: well, the computer just has a look, which word is the most similar. I had to try and tried it out. Things that were the most thought-provoking I picked. So you realize that apparently our language and the language you find on the internet, this language contains such relationship implicitly. Or to put it in simple terms, for instance, the word pretty is used very often with a young woman, and the word, well, successful, for instance, is used together with man. It tells you something about society at large. And the point is not that the computer has made a point of deriving such relationships on purpose, but it just uses what already exists. Well, computers can already write text, but the texts at the basis, on the basis of which the computer has learned, were written by us. You may say, well, this is bad. AI is biased, is completely prejudiced, but AI partially can expose such cognitive bias and distortions. And then you can discuss it and you can say, we don't really want that, but this is what apparently in society at large is what happens. A second question, for my understanding, you had this pretty video about the cute computer interacting with a human being, with a man. How does that work? Is that based on the semantic context which you have programmed in? The computer, the robot asks, how are you? The guy answers, I've got a lot of work. And the robot says, poor you. How did the robot hit upon the idea that work is something negative or stressful and says, poor you, rather than saying, great, super, you've got a job, you've got a lot of work, you like work? Is it because work in the text or the semantic understanding you provide the computer with has such a negative connotation that the robot thinks the right answer is poor you when the guy says, I've got a lot of work? Well, answer, the principle is the computer has seen lots of dialogues like that, so it hits upon relationships like that and can replace dialogues in a certain way. In our project, we did it in a rule-based way. It was about the following. How does the robot come across as a cute companion for household purposes? So we had done it for this video. But if you wanted to implement it with methods of machine learning, you could use standard processes, speech models which already exist, and then dialogues in a certain way would be complemented. You cannot predict how they will be complemented, how they will be added to, but I have a hunch that when somebody mentions work and talks about their work, that the robot expresses regret and expresses sympathy, unless you you talk about successes at work. Well, two critical questions. Vincent, apparently there is a question from the chat. Well, one remark, which relates to your first question. Duban is asking, for instance, those racist distortions, like this vector associate professor man and so on, can you counteract that? You wouldn't train the system with existent data, but you could generate undistorted data, which you could use for training. Answer: this is a useful hint. You need a lot of data for that. When society changes, and we don't have this cognitive bias anymore in our texts, and then you would say, for instance, we don't even start data under 2000 data sets, then maybe distortions and bias which we had in the past wouldn't reoccur. I was shocked lately. I came across my old chemistry kit, and it said, dear young researchers, and I didn't mind, but nobody would write that nowadays. And my husband said, look what it says at the end, this is much worse. And at the end it said, the brochure for the chemistry kit, the great man in chemistry found it much more difficult than you as young researchers. They did great things, and I wondered, This was a renowned scientist, by the way. I don't want to criticize him, so I won't name names. But I wondered whether he had never heard of Marie Curie. As an adolescent, as a young woman, I may not have noticed. Maybe I didn't read it properly. But nowadays I wonder, what is the impact on somebody when you are confronted with something like this? Would you even dare to go for a technical career? This was just one example. I take it in my youth, I was confronted time and again with strange texts like that. But this is a good point you make. As long as we learn from texts which we have generated ourselves, and we are subject to this kind of bias ourselves, the computer will learn just that. There are other examples, and the computer was moved offline, where a chatbot had learned racist utterances because it had been fed with that. And there is another question. Again, the question is off mic. This is your interpreter speaking. Please use a microphone when you ask a question. This is your interpreter speaking. But the answer is, well, I had wanted to show what happens. Of course, you could curate it by hand, that you have a look at the data sets and have a look whether you admit that, and then the machine could learn from that. When I generate this, this is then being censored. This is not desired. So through constant feedback, this would be the fastest way to proceed. You are right. This is not a true solution. This was just hypothetical, that you wait for society to change and then you learn new data without bias. So then the data are censored, the machine learns, there has been negative feedback. Of course, that would be faster rather than waiting for the complete data set having changed due to societal change. Another critical question, you showed facial expression recognition. A few years ago, 2017, we read articles in the press that with facial expression software, which had been programmed using dating apps, and the computer could detect sexual orientation and political preferences. So data from dating apps were input, all genders, all kinds of people, and then facial recognition software recognized patterns in human beings, which were gay, for instance, or heterosexual, in order to be able to tell from facial expressions what their sexual orientation was. From a technical point of view, do you think this is not reputable, or from an ethical point of view, or do you think AI could do that in a credible way? Apparently the result was AI, which had been trained with data on that, got it right, 89% concerning sexual orientation. Of course, in the dating app, people had indicated what their sexual preference was, and that was used as input. So people who looked like that are highly likely gay. Is that technically reputable, or are there ethical problems? Answer, both. You need a model for that. That is very important. There is work where it is alleged, well, I need a short video clip, and then I can predict whether an interviewee is suitable for a job or not. I need a few photos, and then I can tell you what kind of personality that person is. So this is not a reputable way to proceed. This is not sound science. We need models from cognitive sciences. I tell that my students time and again. This is daft. You take data, press a button, you have the scripts running, and then you get an output. And you don't really worry about the quality of the data. It may be possible that you get sort of strange results, but this is not sound science. Thank you very much. We are under a bit of time pressure. We have to rearrange the stage. We will continue at 3:30. Professor André, thank you very much for this super interesting keynote speech. I would like to invite you to stay in this room or to grab a cup of coffee. We will continue at 3:30 at any rate. We will talk about AI and politics, depoliticization through algorithms. Thank you very much.